Okay, so here we have 1.4 that says determine the values of x and y if 3 to the power of y plus 1 over 32 is equals to 90, or the root of 96 to the power of x. So this is quite a peculiar problem since we have two unknown variables and only one equation. So generally, if we're to solve for more than one variable, then we'd have more than one equation. So two variables, two equations, three variables, three equations, and so forth. But in this case, we're only given this, so there must be some kind of trick behind it. My advice would be just to use the concepts that you already know and just apply them and hope at some point something will come up. So our first step to solving this problem would be to square both sides so we can get rid of that square root. If I square this side, I'll have 3 to the power of 2 y plus 1, like that, all over 32 to the power of 2. But 32, I can rewrite it as 2 to the power of 5. I'm trying to get everything in its factorized form so I can hopefully see something. So this will be 2 to the power of 5 times 2, which will be equal to, this cancelled would just give us 96 to the power of x. But again, 96, if you use your calculator and say equals and then press shift and then a button that has fact either underneath it or on top of it, you should be able to, it should be able to return the factorized form of 96, which is 32 times 3, but it will give it to you as 2 to the power of 5 times 3. So I'm going to replace 96 with 2 to the power of 5 times 3 to the power of x. Then on this side, I'll simplify it a bit. We have 2y plus 2 multiplied by 2 to the power of 10 is equal to 2 to the power of 5x times 3 to the power of x. Then once it gets to this point, it requires more logic than mathematical skills, because what we have on this left hand side is 3 to the power of something times 2 to the power of something. It has to be equal to 3 to the power of something times 2 to the power of something. So in this case, whatever's in the powers have to be equal. So I'm pretty sure you're familiar with problems like this. It's the same kind of thing. In this case, you would say x is equals to 10 because we have 2 and 2 as our base for our exponent, which means that there's no way that the fractions can be different and this equation still be true. So in order for this equation to hold, x has to be equal to 10. So 2 to the power of 10 is equal to 2 to the power of 10. Similar thing here. So firstly, we solve for x. So solving for x, we have 2 to the power of 2 is equal to 2 to the power of 5x. That means 5x is equals to 10. Divide both sides by 5. I just equated the powers. I get x is equals to 2. Then 3 to the power of 2y plus 2 is equal to 3 to the power of x. Well, we just take the powers again. So solving for y, would have 2y plus 2 is equals to x. But since we know x, we can substitute 2 in there. And x was supposed to be minus, this is supposed to be minus 10, my bad. So please ensure that you fix this. 2 is to the power of minus 10. That makes 5x equal to minus 10. That makes x equal to minus 2. Therefore, x, when you take the y part, 2y plus 2 is equal to x. This will be minus 2. Take 2 to the other side, we will get minus 4. So 2y is equals to minus 2 minus 4. Divide both sides by 2. You get y is equal to minus 2 as your answer.